Okay, so good evening everyone, bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connex, titled Creating a Thinking Classroom for Primary Mathematics, Part 2, with Laura Jeanne Newman. We have a fairly compact group tonight with mostly experienced participants. I guess you guys were all mostly followed the Part 1 that Laura presented in March, and Laura is also very experienced, so it should all go very smoothly tonight. And small groups are always great in terms of fostering participation. So we certainly look forward to addressing your questions and your comments in the chat box throughout this session. Je voudrais également profiter de l'occasion pour souhaiter la bienvenue à nos collègues franco-ontariens. Cette session est en anglais, mais si vous désirez obtenir des informations en français, surtout n'hésitez pas à me contacter par la suite. En fin de présentation, à la fin de ma présentation, je vous parlerai également de notre première session de la saison en français qui aura lieu dans 2 semaines. We are definitely thrilled to have each and every one of you with us tonight. It's also our absolute pleasure to welcome Laura Jeanne Newman. Laura is a member of the Critical Thinking Consortium, also known as TC Square. She's currently working on the development of a number of resources to support the implementation of critical thinking in the teaching and learning of mathematics. She has worked for over 20 years as a teacher in the intermediate secondary and post-secondary levels. She's one of Ontario's most renowned experts on critical thinking, and she is invited to present at many symposiums around the world. So we are certainly glad that she's with us tonight. Laura will build over the first part of her presentation, and she will try to address concepts such as critical inquiry, conceptual thinking, and what it means to think mathematically during her presentation tonight. So at this point, I'll pass the microphone to Laura and let her keep introducing herself. Laura, please feel free to, yeah, perfect, thanks for jumping in, and go ahead. Thanks so much.
Thank you, Michelle, and good evening, everyone. Welcome to a session. I don't know what the weather is doing in your part of Ontario, but in Toronto and the Greater Toronto area, we've got lots of rain and thunder and lightning. So I just want to make sure that you know, just in case if anything goes on with power outages and I get kicked out for some reason, I'll just immediately come back on and we'll continue the session. So I thank you for your patience. I'm just taking some preemptive action. I also would like to, knowing that this is part 2 or session 2 of us here getting together, and I'd like to see if everybody's okay to use their writing tool. I'm going to ask just very quickly on this first slide, if you were at the first session, if you're returning, could you just write an R anywhere on the first slide? And if you're new to the session, could you just place an N on the first slide? Thank you very much for sharing that with me. It's important for me to know who's returning and who's going to be new to the session so that I know how much background information I need to fill in some of our conversation with the new folks that are joining us. And as well, thank you very much. I look at the sorting that you guys did. It was fabulous. I have all the R's on one side and all the N's on the other. Great critical thinkers already in the group, so thank you so much. I'm going to start off, given the number of new people, I did build in some slides where I might do just a little bit of a review. I know for all of us it's been some time ago that we had the first session. So I just want to highlight what we did and where we were at, and maybe through a minds-on activity kind of bring us all up to speed in terms of the work that happened last time, and then move forward with our new learning for the session. So in our previous session in March, what we did is we focused on creating opportunities for quality thinking, and you'll see here as a framework, the Critical Thinking Consortium promotes the development and creation of a thinking classroom through 4 fronts. And we won't get through all the 4 fronts in this session. I don't want to be very content-driven in our sessions in an hour and a half. So last time when we got together, we really focused on creating opportunities for thinking. And what we did there is we looked at a series of examples of how you would invite children at the primary grade levels to engage in critical thinking and mathematics. And we looked at a series of different examples, and we deconstructed them and explored them and surfaced some important ideas. So what I would like to do, just so that we can kind of step back a little bit, part of our practice is to encourage sustained thinking as well as quality thinking. And so it would be very difficult to have everybody in the group sustain that thinking if I didn't iteratively go back a little bit and just kind of review a bit of what we were doing, and so that you can make the connections you need to make in your learning to move your learning forward. So what we did in the first session, as we explored a number of different examples, and I know you're not going to be able to see the details on the slide of all these examples, but that's not important, because what I'm going to do is I'm going to very quickly walk you through them. And I'm going to ask you, so as I walk you through the different squares and the activities or tasks that children were invited to do, and this was in fact a kindergarten class that we did this work in, and I'm going to ask you to think about what order would you place these critical thinking tasks or activities to create the most powerful learning for your children. So I'm focusing on, and of course you're going to be thinking about what makes learning powerful, knowing the children at these grade levels that you work in, and you're going to be looking at how you would sort them or order them in an order that creates the most powerful learning for them. So in the first slide, you'll see that what the children were given is some 2-dimensional shapes, and they were actually placed in hula hoops for the children initially, and the children began by taking a look at these as representations of a play area. Typically we'd call that play area a ball pit, but I didn't want to call it that because I didn't want to sway the thinking in any way with the children. So they got to see 3 different play areas in the sense that they knew that they'd be jumping in and playing around with on top of all these different geometric shapes. And they were asked to determine, as Anna was going to be a friend who was joining them, how would they convince Anna which is most likely the most pleasing play area. So the first slide has them just thinking about how would they convince Anna that this is or one of these is the most pleasing play area. The second slide, B, actually has the children creating a play area to convince Anna to come play with them. And they've got various 2-dimensional geometric shapes they were offered to consider, and they were to actually create one of these play areas. And the third box, C, what you'll notice is that, again, we have the 3 play areas, and what the children were invited to do is see if their thinking had changed. Have they decided that one play area is more pleasing than another play area in light of their previous thinking, in light of a previous decision that they made? In slide D, what the children were doing is actually placing, and you can't see it here, I don't think, because the tools are covering it up, but they were to order these play areas from most pleasing to least pleasing. So they were ranking them, and they were considering criteria that they had been using throughout the series of lessons, and this took a couple of days to go through with the young children, but then they were rank ordering them. And then finally, you'll see on in box E, you can see that the children here were being invited to assess each of the play areas to determine how pleasing each of them are. So what I'd like to invite you to do, and actually ask you very quickly to put your ordering in the chat box. What order would you place these tasks or activities, these thinking tasks or activities with these very young children? What order would you place them in order to create the most powerful learning for the children? I'm going to give you some time to think about that, and then ask you to place the order in the sequence of letters in the chat box. And so, for example, and if you have questions, we're a small group, so please don't hesitate to put up your hand and let me know that you'd like to, or put a question in the chat box. But if I were to be doing this, I might model it by saying that I would do activity E first, then B, then C, then A, and D. So what order would you be placing them in to create the most powerful learning? Yeah, that's an excellent question, Debbie. I would order them in any way that you think would be most impactful to the learning of the children in your classroom. So you could choose, so you might choose easiest to most challenging if you think that's most effective. I'll give you another minute or so to do your thinking. So this is really wonderful, and I'm very excited because I noticed that I don't think that there's one single person who's ordered them in exactly the same way. So what I'd like to know from you then is, tell me a little bit about what drove your ordering. What did you consider, how did you decide on what was most powerful, and how did you decide on your ordering? And again, you can put your comments, you can either take the mic if you'd like, or put your comments in the chat box. How did you decide what order to place these in to create the most powerful learning? Okay, thank you. So you want to show the children first what they're expected to be able to do so that they understand the question. That's great, setting context. Thank you. Okay, starting with B, because that's where you'd want them to start so that they understood what it was that they would be working on throughout the sequence of activities. Okay, starting with motivation and engagement. What's going to motivate the children? What's going to engage them? And then allow them to synthesize and pull everything together. Great, thank you. I couldn't find starting with. So A, D, and E allows them to make a judgment. Okay, great. Okay, so you've raised two very interesting ideas, and I'm so happy that you have as a group. One is, how do we motivate, how do we engage? And where would I start if that was what would create the most powerful learning for my children? On the other hand, how do I make sure that the children understand what they're expected to do? Where would I begin if they had a clear sense of what it was that we, as you and I, as teachers, would expect them to be able to do, and in turn, allow them to understand that, so they clearly understand where their learning journey is going to go. So this is, by the way it was presented when we first met as a group. And I'm finding it fascinating. By the way, just so I can clarify, we're starting at the top left corner, moving across the page, and you'll see the arrow goes down, and then at the bottom it's going from left to right, just so that there's no confusion of what it is that I'm representing. And you'll notice here that in my representation, I would have had the children starting with reasoning, and then connecting back to that reasoning so that they can clearly see, so that they can clearly assess what it is that they were doing, and they could self-direct and self-correct in terms of their thinking as they moved to the third activity. And then going back and after they've done that reflecting and developing a sense of what the activity was and what they were supposed to work on, have them selecting and representing tools and strategies, and ultimately then communicating and giving them an opportunity to communicate their thinking. Do I think that this is the only way? In fact, I have to tell you that this is the way I presented it, but when I work with children in the classroom, I actually would repeat that last slide where the children are communicating, and I give them an opportunity to see what they would do with the task, which is my culminating task, where I'm hoping that they're communicating clearly with an extensive justification. And I would start with that task and let them start generating some ideas, and then begin with the reasoning, where the children are making conjectures and starting to develop and develop the capacity to have what we call the intellectual tools to be successful. So let's talk a little bit about why is this order important? And what I did is I listed a number of possible reasons, and what I'd like to do is invite you to check off which reasons you would support, and if there are any others that you can think of that aren't there. But basically, these are reasons that I use in order to generate an order. So this is what I would use as my criteria to support powerful learning. What was your criteria to support powerful learning? And why is the order important? What are the objectives that we're trying to achieve with the children in the classroom? So again, I'm going to invite you just to place, place a check mark next to the boxes that you see are possible objectives or criteria to determine whether learning is powerful, and see if you want to add anything else. And please add anything that you'd like to add in the chat box so that everybody can see it.
So mobile users, you are not able to access icons, so you would write in the chat box, and then for computer users, you use the bottom tool on the vertical tool strip, and you can just drag icons on the slide.
Thank you, Michelle. Okay, so I'm seeing that many of you are identifying the relevancy of a lot of these, and these are possible objectives that we would consider. And so I think that's wonderful that you're noticing that. I'm curious, is there anything that I didn't put in there that you might think would be important? As you thought about what learning, what powerful learning is for children in primary, what were some of the things you were thinking about? Is there anything missing from this list?
There's nothing to read.
Okay, so a connection to the mathematical processes of significant importance, absolutely. And multiple entry points, starting with something that is accessible to all children. The children that you know are going to struggle the most, and the children that you know are going to need an opportunity to extend their thinking with. And by the way, I think it was Debbie who had said, could I not start with them completing the task and then end with them completing the task? And absolutely, that was one of the things that I had suggested, that when I actually do this in the classroom with children, or I model it in the classroom with children for other teachers, that's where I would begin. So extremely important. Important because it allows them to go back and revisit, but also important because they get a really clear sense of the learning growth that they've experienced. They can see that at the beginning they weren't quite sure what it was that they were doing or why they were doing it. They were generating ideas, and they might have had some ideas, but by the end of a sequence of learning, they can experience the growth in their learning and then apply it by doing the task over again. And the constructivist approach is really important. Again, it gives the children a place to start generating their own ideas. And that's key because that's what really gives children voice and ownership over their learning. So thank you very much for sharing that. In summary, what I wanted to highlight as a key message from the last session is that with critical inquiry or sustained thinking in a classroom, the key, or the most important key in design for the children is to sequence questions that are designed to invite all the children to think critically all the time in a connected and iterative manner. What I noticed that it happens in a lot of classrooms is teachers understand and believe in the importance of quality thinking for their children, but also struggle with what do I do with the content, and how can I have them think in the absence of background knowledge. And so I think it was Debbie who had written that constructivist approach, giving children to be able to construct their knowledge as they engage in the thinking and as they engage in the learning, I think is really, really important. And so there's every opportunity that a child has in the classroom, gives them an opportunity to think critically, make mathematical decisions that they've learned how to make well, so that they own the learning process, and so that they actually possess the capacity to be able to self-regulate, self-assess, and think about where they need to go next. I always talk about this as being the best form of differentiation, because it doesn't put on me as the teacher that I have to create something different for every child, or I need to figure out what every child at the very first, from the very first time I meet them, what every child prefers to do and how they prefer to do it, and I'm not saying that getting to know the learners is not important, but I think it takes time to get to know your learners. And so the best way to get to know them is by having them surface who they are by the decisions that they make right from the get-go. So I wanted to highlight the importance of the connections, the sequencing, and that the critical thinking is ongoing in an iterative manner. So as children move forward with their critical thinking, they get to step back and then they move forward. I don't know how many of any of you have seen Ann Davies' work in assessment, but she talks about a forward-moving loop in assessment. And this is basically what we're trying to do in all teaching and learning of children in our classrooms is that there's a forward-moving loop that pushes very gently and safely, pushes our children forward in their learning as they engage in thinking. I want to move now to the attributes of a quality mathematical thinker. And I want to ask you, based on our conversation so far, to what degree can a student be good at math without critical thinking, knowing that the thinking that a child does or a student does is really around the mathematical processes. We talk about the mathematical processes as being the way mathematicians do and think through math. And these processes are really critical, and these are really, really important. I've noticed that there's a question in there about who proposed a forward-moving loop. Ann Davies' work in assessment was probably the pioneer in talking about that in our work in assessment. I think that what we're doing as a consortium is, instead of having our children constantly just reflecting back, having them reflect back for a very clear purpose to move their learning forward. And so we talk about thinking forward for our children, constantly having them think forward. And that's been very clearly the work of the Critical Thinking Consortium and the work that we've done in sustained increase. So thank you for asking that question. So I want to go back to this again and have you consider these mathematical processes. And I would say that there's probably one other thing that I would add to this that is not clearly apparent in the documentation of what a mathematician does and how a mathematician thinks, and that's that a mathematician also thinks conceptually. Now, we've talked a lot about mathematicians having to develop conceptual understandings, and we've done a lot of work in that area, and then the example that we're going to work through in this particular session today is going to focus on conceptual thinking because it is so important in empowering our students how to think mathematically independently and how to make sense of problems that they are given and that they face in mathematics, empowered to be able to do it independently on their own so that they're not always relying on the teacher to show them how to do that, to show them what that thinking is. So I'm going to invite you again, to what degree do you think a student can be good at math without critical thinking, but through the lens of the mathematical processes? What are your thoughts? And again, sharing your thoughts in the chat box. Or even just jotting down, let me give you some options to consider as a good critical thinking facilitator, and I would offer you to choose across that they are significantly important, somewhat important, or of little importance. So what would you choose? Are they significant? Is it significantly important, the ability to think critically, somewhat important, or just a little important? So I'm noticing that most of the comments and the responses are showing that there's a belief that critical thinking is significantly important. I noticed that one of the comments talked about how at some point children need to learn to very quickly be able to do mental math, and I would say mental math actually does require critical thinking because I think it requires a child to make a decision about how to best deconstruct numbers, break them down in a friendly way in order to most effectively and efficiently come up with a numerical response. But I do believe that there are some things around procedural learning, asking children to practice recall, these types of algorithmic, procedural types of computational types of learning that I think many math teachers believe are extremely important. And if that's one of the things that you're seeing are important in a math classroom, then of course you wouldn't say that critical thinking is of significant importance. You might say that it is somewhat or somewhere in between that. I'm going to argue that I do believe that proficiency in computational, procedural, algorithmic thinking is important, but I'm going to emphasize that I also call that thinking, because I think that if we just develop in students a capacity to recall in the absence of mental processing, then the learning will not stay with them for extended periods of time, and they will lose an extremely important opportunity. And that's the opportunity to make the decision about, and you'll notice here when we talk about selecting tools and strategies, I mean, these are selecting computational tools and selecting strategies that we may use that might be, that, you know, in many cases might be procedural or algorithmic, but how do they select these? So that brings me to the next slide, which gets me, in which I show very clearly that in all of these mathematical processes, there's always a qualifier that highlights what the students actually have to do to engage in the mathematical processes in a productive manner, in an effective manner, in a useful manner that's going to help them be successful. So if you take a look at these, you can see that problem solving, and I put problem solving at the top because I think sometimes we have a very narrow definition of what problem solving is, and it's unfortunate that we believe it's giving children a word problem, or we believe it's giving children, you know, a task that they're unfamiliar with, but hopefully they'll know how to make the decisions about how to solve the problem using the tools and strategies and their reasoning abilities to do so. And I place it on the top because really what I like to talk about is effective problem solving is really when teachers problematize every aspect of the curriculum. And I don't think that there's any aspect of the curriculum that can't be problematized. So I put it on the top there also because I don't think that I can solve any problematized aspect of the curriculum, or a child can solve any problematized aspect of the curriculum without using all of the other processes. And you'll notice here that the qualifiers in the other processes are really important. So how do I know? I know that I need to represent things, and teachers are inviting their students to represent things in many ways, but how do I do that effectively? What does it mean? So if I'm asked to represent the problem visually, if a child has no idea, what criteria is required to know what that means? In other words, does your representation fit the nature of the problem? Does it actually match what the problem is asking you to do? So is the information in the problem consistent with the information that's being presented in all the different representations? So effective representing is really, really important, and children needing to know what the criteria for effective representing are is essential for them to be able to do it well. You'll notice that, you know, children need to know how to make appropriate, in other words, meaningful and relevant connections. Children can make all sorts of connections. It doesn't mean that they're going to be helpful. So we need to raise that with our children and say, that's a really interesting connection you've made. Can you tell me, is it helpful for solving this problem? Is it helpful for you understanding this better? And getting them to understand, again, there's criteria involved. The same thing with the selection of computational tools and strategies and reflecting. Is the reflecting that they're doing meaningful to them? Is it something that is going to help them grow as a mathematical learner? And is it continuous? We want our children to begin with reflecting, and that's why we ask them right from the get-go to make a conjecture. In light of not having a full body of knowledge, a full body of information, What would you do? What would be the best thing to do to solve this problem? And that's starting them with meaningful reflection that they can revisit over and over again so that they can experience growth in their learning, so that they can self-regulate and self-assess. And all of this is based on the ability to reason and prove in a sound way. Clear and concise communication, I think we talk about that all the time, but I often wonder if we're expecting our children to communicate clearly and concisely too soon. What are we asking of them in terms of the cognitive demands? So typically what we encourage children to do is muck about with all of the thinking through reflections and the use of criteria connected to all of these mathematical processes. And then ultimately, once they've done that thinking, focus on how are you going to clearly and concisely communicate the thinking that you've done. Now that you've messed about with it, you feel comfortable with where you're at, you've consolidated it, you've pulled out what's not necessary and only highlighted what is necessary, only then can we actually engage our students in clear and concise, effective communication. There's a question in the box that says, how do we explain to our students what effective means and looks like? And I think that's a fabulous question. And in our example that we're going to go to very shortly, I'm going to try to show what that means, because it means different things in different contexts. So I'm going to start having us play with this, and if I haven't answered your question by the end of the session, please raise it again for me, because I think that's really important. The other thing I want to highlight, and this is something that we talked about last time, is that all of these things, all of this quality decision-making through the mathematical processes requires some generalized metacognitive thinking. So a student who generates and assesses plausible options is going to be able to make effective decisions through the mathematical processes. A child who uses criteria to support that decision making. And here, this is mathematical criteria. Often I'll go into a math classroom and the teacher will be teaching a lesson about something and they want the children to learn the math through, say, equity and fairness. And I think that's really nice to integrate things that way, but then the criteria they use is not mathematical criteria, it's criteria that solely draws on what's equitable and what's fair. And it's quite easy to translate that into mathematical language, into mathematical criteria for children. Children who make reasoned decisions and use relevant mathematical evidence. These are the four generalized metacognitive criteria that children need to use every single time they engage in quality decision making as critical thinkers in math through each of these mathematical processes. So let's take a look at what that looks like and how we're going to do that. And I want to start off with the question, in light of all of these ideas, what should we be teaching? What should we be assessing? If we want to empower our children to engage in quality thinking through all of these mathematical processes using these generalized metacognitive aspects or criteria for thinking, how do we teach it? How do we assess it? And so I want to give you a moment. I'm not going to ask you to share this time, but I want to give you a moment just to reflect on that before we go through an example and we explore that example through this lens. How do we teach this? How do we assess it? So one of the things that I like to encourage teachers to make very explicit to their children is what is critical thinking and how would I have my children doing critical thinking in math and how would I assess that in an ongoing way? How do I gather diagnostic evidence if they're doing it? How do I gather formative evidence that they're doing? And then in the end, how am I being able to comment on their ability, their ongoing ability, to see if it's growing in any way? You'll notice here that these are the 4 attributes that I just highlighted, and what I encourage that teachers do is use them as generalized criteria to help them monitor their students' thinking growth, their students' thinking capacities. And I'm not going to spend a lot of time on it because I think this is a whole new session on assessment and how we assess for thinking. But what I want to do is just highlight that if you want to go back to this and take a closer look, what I've done is I've separated what qualitative criteria are when I'm actually looking for this in student work, student conversation, in my student observations, and what are simply requirements. I want my children to understand that when someone is thinking critically in mathematics, they begin by either highlighting the options that they have or generating options. And most often, we do a pretty good job of this in our classrooms. I think that we've done a really good job when we shifted from procedural, algorithmic, computational learning to learning that, I have to say, shifted the pendulum in the opposite extreme. Let's surface thinking. Let's just get kids think about all the different ways they can represent this, or all the different strategies that they can use to solve this problem, or all the different tools that they might be able to use to solve this problem. Those are the options that we have our children consider. Sometimes we want to highlight all of those different options, particularly for very young children, because they don't possess the background knowledge yet to be able to know what they are. But we still want to encourage them as we possess them, as we highlight them, to be able to identify that these are options that they are considering. These are the mathematical possibilities that they get to explore. And this is what makes mathematics really exciting. But sometimes in math classrooms, I find that we get stuck there. And even though we try to consolidate learning, the consolidation isn't really about what they need to be able to do with those options. In other words, how do I select the most appropriate computational tools, strategies? How do I get there? The second attribute here is having children recognize that they're making decisions, but they aren't any decisions. So for example, one of my biggest pet peeves is when I hear the word guess in a classroom. And it doesn't matter whether I'm working with 3-year-olds or I'm working with 18-year-olds. I really don't like the word guess. And it brings me back to, I don't know how many of you watch The Big Bang Theory, but there's an episode that if you have an opportunity to look up, it's absolutely fabulous. Leonard walks into the room. I don't know if you're familiar with Big Bang, but it's about a group of physicists. Some are applied physicists, some are theoretical, and they're friends and they work together. And Leonard's, trying to get a girlfriend, and Penny lives down the hall, and he's hoping he'll be able to date Penny. But he walks into the room and he says to Sheldon, who by the way is a fabulous critical thinker as a theoretical physicist, and says, "You'll never guess what just happened." And Sheldon goes on this rampage about that there are telepathic dolphins, and he tells this long-winded story about what his guess might be that's completely unrelated. In other words, I would say he didn't make a good inference or conjecture based on Leonard's question. So I try to encourage that we stay away from the word guess, and we make sure that the children understand that what they're doing is they're making mathematical decisions that they need to be able to justify, that they reason through, okay? And they do that by considering those options, assessing those options in light of criteria that are helpful, that are related to what it is that they're doing, and using appropriate evidence. And again, you'll notice that there's a lot of qualifiers in there that really highlight the necessity of good critical thinking. I also want to highlight what I really want to get to in part 2 today is how do we build the capacity of our young children to engage in quality thinking. And I want to highlight the intellectual tools that are central to providing children and all of our students with that capacity. And you'll see that there are 5 intellectual tools: background knowledge, criteria for judgment, thinking vocabulary, thinking strategies, and habits of mind. And I'm guessing that as you look at these, none of these are a surprise to you. I'm sure that as you wonder what children have to do in order to engage in quality mathematical decision-making, quality critical thinking, that these are all the things they need to think about. They need to wonder about what background knowledge do I need to access. They need to figure out what criteria that they're going to use. They need to understand in a meaningful way thinking vocabulary. We use words like conjecture, compare and contrast, rank and order, reason and prove. Like all of these things, we use these terms all the time, but the children, for the most part, have no idea what that means and what metacognition is required for them to do that successfully. So we want to make sure that we really, really expose the meaning of that kind of thinking vocabulary that we have embedded everywhere in our curriculum. Then we want to be able to give our children strategies, thinking strategies. And these strategies are to help them organize their thinking. Often I notice that a lot of the work that's been going on in classrooms, which has been really neat, powerful work that we can just bounce off of and continue to grow off of, is that children kind of scatter their thoughts everywhere. And that's wonderful, and I think that's not a bad thing at the very beginning. But ultimately, what we want them to be able to do is say, okay, so I've done all of this thinking. How do I organize it? Do I have a strategy for organizing this thinking? And lastly, the habits of mind that we want to nurture. We want to make sure, and we talk about, we don't teach habits of mind, but we do teach children how to use the most appropriate habits of mind given various problems that they're facing in order to meet the cognitive demands of those problems. So these are important 5 intellectual tools. I want to highlight that these 5 intellectual tools can only be developed. We can only build the capacity of these intellectual tools if we do one very important thing, and that's that we have our children think to learn mathematics while they simultaneously learn to think mathematically. What this means is that on Monday, Tuesday, and Wednesday, we don't say, here's all the mathematics we want you to learn. I might tell you it, or I might ask you to recall it, or I might ask you to memorize it, and through repetition, hopefully you get it. And then on Thursday and Friday, we say, okay, now we want you to think about it, think mathematically. What we want is every day, what we need is every day for our children to look at the problem, look how the teachers problematize the mathematics, look at how the world is full of problematized mathematics, and have them think to learn the mathematics so that they can become proficient at learning to think mathematically. It is very difficult to become proficient to think mathematically unless I actually practice it every day. And so here's the experience that I see happen in many classrooms, and I'll be quite frank with you, mostly in kind of intermediate, secondary classrooms, is the kids get a lot of content, and then on Fridays, they get a really, really difficult, challenging problem in an unfamiliar context that requires them to use all of those mathematical processes effectively to solve the problem. And Friday, they sit there and they try to work on the problem. And the teachers always say to me, I don't understand why they can't solve these problems. They're horrible, and they say this to me directly, they're horrible at thinking. And one of the things that I ask them is, so how often do they get to practice, explicitly practice thinking mathematically? So we need to be thinking about that as we create learning opportunities for our students, and see that the thinking, the mathematical thinking that goes on is through the mathematical processes plus the addition of computational thinking through the capacity and the tools of being a good critical thinker. So let's explore what that means. I've chosen this example, and I don't know if some of you have been to other sessions that I've done, but I share this example quite frequently, and I do it because, to me, it's probably the most important thing, the most important concept, mathematical idea that we can teach children. And it's important, most important, because the concept of equality weaves itself through every grade level, through every strand, through every concept in math. And it's critically important. You'll notice here that I put this thoughtful and informative investigation of the concept of equality. It's critically important that it starts at a very young age, that children really understand what the concepts of equality or something being equal really means. And unfortunately, there's a lot of misconceptions out there around what that is. So this is the example we're going to explore. And I'm going to begin, and you'll see my process is going to be very similar from the slides that you ordered earlier on in the session today. So I begin with asking the children a question. And this, by the way, was designed for a grade 1 class, and I want to give you the context of the first time, the first class it was implemented in. Now it's been implemented in a lot of primary classrooms because teachers really, really love it, and they see, when they see it modeled, they see the power of it. But I take a look at where the grade 1 students are and where I want them to be at the end of them thinking about equality. And I give them a question that I think is going to be accessible to all children over time, but I also think is going to challenge a lot of students and encourage that their thinking is extended and that their learning is extended. And so the children are given this numerical equation right away, and they're being asked to show this equation using any of the following items. And I give them 5 items because I think it's important that in a classroom where hopefully you are flowing in and out of independent work to small group work to larger group work, back to the whole group and back again to independent work, that there's a fluidity, a flowing fluidity of how children are working in the classroom. It's important to have something that is common for them to talk about. So this is where I place a little bit of a restriction on what it is, the tools that I'd like them to use or the visuals that I'd like them to use, so that we have something in common that we can talk about. Now, you could use any manipulatives that you want in your classroom, but just ensuring that all children have the same access to all of the manipulatives so that they can collaborate, they can share their thinking, and we can consolidate their thinking in a meaningful, consistent way. So the children do this, and you'll notice I start with a driving critical inquiry question and task, and the students provide a response to this task. And so this is what the students initially do with their initial response prior to any instruction. They're not getting any instruction at this, any direction at this point on how to do this. And so what I'd like you to do is invite you to consider, with the 5 intellectual tools in mind, which of the 5 intellectual tools do you think the children will access in order to begin their learning at the very start of this, inquiry? And again, I invite you just to check off the box if that's the easiest thing for you to do, or you can use the chat box. Okay, great. I'm seeing they're going to demonstrate what they do and do not know. Anna Marie, would you like to share your thoughts using a mic?
Hi, can you hear me?
Yes, thank you.
I was thinking background knowledge, because you have to start with background knowledge.
Okay, absolutely. The one thing that we're going to draw out of here is what background knowledge are they going to start using. So background knowledge is probably the key one in this activity. Do you see any of the others?
They're going to need to use their thinking vocabulary, or vocabulary. The symbols are their vocabulary in this case.
Okay,
So here, they're going to draw on some thinking vocabulary. And you're right, this is a lot about symbolic thinking. And again, I'd have to tell you, we'd have to do a whole session on symbolic thinking alone, but it's key. They're going to draw on, they're going to draw on their symbolic reasoning and being able to decide what they're going to choose. Okay, criteria. Can you tell me a little bit about the criteria? Criteria.
And Anne-Marie, you don't have to do that because I noticed somebody put in the chat box criteria. I'm just curious about what criteria you're imagining that children are going to use.
Okay.
And I'm really glad someone has done that. So let me see if this aligns with your thinking. What we'd want to do next, see, we're inviting children to do an activity in the absence of any background instructional, any background information, any instruction. So they're not drawing on the learning that we've offered them in the classroom. So in essence, they're being invited to make a conjecture. What do you think this is going to look like? Now, what's really important is the criteria behind conjecturing. And with very young children, if I were to ask them, can you tell me what you were thinking about? That's a little bit tough to pull out of kindergarten, grade 1, even grade 2 students. So what I want to do is I want to build the criteria into part of the instruction so that the children know what it is that they need to do with their thinking, metacognitively, in order to start figuring this out. So one of the things I ask them to think about is, what do you see? Can you list everything in the problem that you see? And they're fabulous because they just start listing everything. I mean, I put it in order, but they'll say, well, I see an addition sign, I see these are the numbers I see, these are the pictures I see. And this is really important because often what we expect our children to do is decide what's relevant information and not what's irrelevant or unnecessary information without teaching them that, first of all, they need to pay attention to all the details. Okay, so, and I think this is great. What do you notice? But I want to make it even clearer. I want to say, what do you see? What are you seeing on this page? What are you seeing in the problem? In other words, what clues do you see? And ultimately, I want them talking about evidence. What's the evidence that's being provided? You're a detective because you're about to conjecture. What is the evidence that's being provided? And they start listing all of these things. Now, here's the other important metacognitive criteria. 2 important metacognitive criteria for conjecturing. Have they paid attention to all of the details, the clues in the problem? Secondly, or in the task. Secondly, have they thought about what they already know and understand about what they see? These are 2 very, very simple metacognitive criteria, but I can guarantee that your children are not using them. The majority of the children in your classroom aren't explicitly exploring the problem for clues and identifying all of the clues, and then asking themselves, what do I already know and understand about this? A couple of weeks ago, I was in a grade 8 classroom, and I was really shocked that I had to tell the students in this classroom that I gave them a really complex algebraic equation to solve. And it was really a grade 9 algebraic equation, but they looked at it and they said, we can't do this, it's impossible. And I said, I trust in your ability that you can do this. You need to trust in your ability. Let's take the following steps. And I said to them, what evidence do you see? And tell me what you already know. And they listed, like, the list of things that they already knew and understood was so empowering to them. But one of the things that one of the students in this classroom said to me is, I never thought I would have to actually think about addition and what addition means because I'm in grade 8. And I said to them, you come in with, and as your children move through the grades, they come in with a growing
I don't know if you want to call it basket, or a growing amount of mathematical knowledge and understanding. And they need to be thinking about that whole set of knowledge and understanding every single time they're faced with a problem. The issue is, when we teach math in a classroom, they feel like, oh, I'm learning addition today, so that's all I really need to think about. And this happens right across the grades. I'm learning about fractions today, that's all I need to draw on to solve this problem. And it isn't. Really rich, complex problems require that children draw on everything that they know and understand. So this makes it very explicit, and you'll see these are some of the things that children will do. They'll say 5, 2, oh, counting, oh, look at the way I can represent it. This is really powerful. By the way, I then, without telling them what's important or not important, I invite them back to ask them to show the equation a second time. Okay, so they go back to this task and say, okay, you did this initially, now I want you to go back again and show the equation, now that you've thought about all of this stuff. And it's fascinating to see the nature of the learning that happens in one small step, because I've taught them how to do the metacognition behind conjecturing. What is most likely, given that I know I don't know everything, but I do know a lot of stuff. Okay, so a good conjecture draws on all the relevant clues, and it draws on, or is consistent with all, or fits with all the relevant clues, and fits with what we already know and understand to be mathematically true. So this is really important, and notice how it's made really explicit. So now take some time and think about, what tools do you see, intellectual tools do you see at play when we do this really explicitly with the students, with the children? So I'm hoping that as I ask, what do you know and understand, what do we know about what we see, we're drawing on background knowledge. I'm hoping that you're seeing that these two columns are actually presenting the criteria for a sound conjecture in mathematics. I'm hoping that you see the role of introducing the language, because at this point I would be saying to the children, you're trying to figure out what's most likely, and you don't know everything yet, and that's okay. And you know what that's called in mathematics? Because that's a really important thing we do in math, and they learn the thinking vocabulary of a conjecture, and they understand what a conjecture means. This, by the way, giving them two columns and asking them to identify everything they see and then connecting everything that they know and understand about each of the things that they see, is giving them a thinking strategy. And notice the habits of mind, especially the paying attention to detail that is being nurtured when we ask them to do this. So I want to point out that many of the flaws in mathematical reasoning are the result of a weakness in these two metacognitive criteria. One is students possess poor knowledge, background knowledge, or conceptual understanding, or they possess the poor habits of mind to gather all the details and clues in the questions. So it's fascinating that if we address these two metacognitive criteria and make them explicit to the children, and by the way, I don't have to tell them you're using criteria. At some point I will like to introduce the language because it's important, because I'm empowering them to know this, but over time I want to be able to see if they start doing this independently as a class. And I don't know if you're familiar with this particular video clip. I'm not going to show it, but I don't know if you're familiar with in this video clip, what happens here is that there's a misconception around place value, and there's one of the actors in here, and it's slipping my mind their names. Can you believe it? Abbott and Costello. Thank you. Sorry, I just needed to draw it out of my long-term memory. So you'll notice here that Abbott and Costello, what they're doing is, one of them says, well, 13 times, I've got 28 cookies, or 28, I think it was muffins or cookies, and I've got 7 sailors, and I need to have 13 of each of these cookies or muffins in order to make sure that I can share the 28 equally. And I don't know if you've seen this particular, if you can, try to Google it, but it's fascinating because you'll notice that what comes to play is that the misconception, the conceptual misconception, comes from poor background knowledge and understanding, not understanding place value, and not paying close attention to details. Because if you simply took a look at the cookies or the muffins and saw that they were 28 and physically understood what the number 28 meant and how it can be broken down, he wouldn't be having any of the issues that he has. So why should we have the students start with the final assessment task? And again, I'm just going to draw out why this is important, but I think that you'll see this in what it is that we just did. I need to draw out the background knowledge that the students possess. I need to understand whether they're coming in with background knowledge or an understanding that is not mathematically true. It's a reality, and I tell teachers this, that I teach mathematics through thinking because it shows the mystery and the excitement behind mathematics, but the reality is ultimately mathematics is about absolute truth and correct answers. But the only way students can get to those absolute truths and those correct answers if we give them the tools to be able to think mathematically in a proficient way. So I want to draw out, do they have any, are there any misconceptions? I want them to predict mathematically, because this gives them a starting point, by the way, a point of comparison against which they're going to measure their learning growth. Because you notice when they did it the first time, and then I had them focus in on the 2 metacognitive criteria, and they go back and do it a second time, they're going to see learning growth. And it's fascinating to have them recognize that. And again, I want to draw on existing misconceptions. So then I want to introduce, and you'll probably be familiar with this, an anticipation guide. And I introduce an anticipation guide because I want to launch their learning, giving them something to think about that they're going to draw on throughout the learning sequence. So you'll notice in my anticipation guide, I build in misconceptions and I build in the criteria, the factors, the thinking factors I want them to consider right in the anticipation guide. Because what this does is this, as a minds-on, it puts their minds onto these things. It gives them something that they're going to think about. Now the children sit down and do this in pairs, and you'll notice they're grade 1 students. I just ask them to circle or color in the happy face and the sad face. And again, right away gives me a sense of their misconceptions or what they're struggling with. But notice here, when I do an anticipation guide in mathematics, again, I'm drawing on their background knowledge. The criteria for judgment, I've built in criteria for judgment because I want them thinking about these things, and as they go through a sequence of learning activities, they will think about each one of these things, and we're going to work on them and uncover them and lead to a deeper understanding of each of these. And I want them to, I ask them, is it true or false? Truth, whether something's true or false, is critical to mathematical understanding. As I said, math is all about absolute truth. It's about truthness and falsity. So I introduce that as thinking vocabulary. And the anticipation guide is a thinking strategy. I give them something that they can start thinking about, and they're going to return to it again and see where it goes. Now, the habits of mind that are being nurtured here are several. One is, again, paying attention to detail. The other is to encourage flexible mindedness, because I've given them a number of things to think about, and I want them to go back and think about these. These are the options in terms of the properties I want them to think about when it comes to the concept of equality. And I want them also to be very fluid and flexible-minded in the way they draw on these things. And so you'll see that in the activities, how that works out. So here's the first thing they do. And again, I'm focusing on conceptual thinking because I think it is probably, if there is any thinking that you do in your classroom, I would say, even without considering the mathematical processes, begin with conceptual thinking. Because conceptual thinking is important in math, and empowering our students in so many ways. One, it teaches them to read problems for meaning. I can't read a problem, I can't look at a problem and understand what it's asking me to do if I don't see the concepts at play in the problem. So this is really important. So focusing on conceptual thinking, they take a look at two examples, and you notice I start with a very simple example. In fact, this is what I would use in kindergarten as a kindergarten example. And I would go through a series of these with kindergarten students, and I start by asking the children and partners to replicate what they see. So they get actual, little cards with these pictures, and they recreate them. And I start, they don't get exposed to the false example. They don't see the false example, but only the true example first. And I ask them to recreate it. And the reason why I ask them to recreate it is because I want them to build their mathematical vocabulary so that they can discuss and communicate their thinking orally, both orally and through the use of concrete materials. So what the children end up doing is they place these four pictures in their precise placement, and they put an equal sign in the middle, and they place the four pictures in the precise placement, and they say, oh, they count it through 1, 2, 3, 4, and count it through 1, 2, 3, 4, and they realize that there's 4 items of exactly the same things on both sides. Okay? So I want them starting to connect with what they already know and understand to be mathematically true, so that they can compare and contrast this now with a false example. So they go through the same thing with the false example, and inevitably they recognize that it's the same picture, but the only difference is the number, the quantity on each side is not the same. Okay? That's a starting point for an understanding of the concept of equality. It is not a full conceptual understanding by any means, but it's a starting point. But notice that what we're doing as the first activity of conceptual thinking is to get the children compare and contrast. This is what they surface, and what I document is I document their thinking. I don't annotate their thinking. I simply document what it is that they're telling me. And this is important because I want to keep thinking in the hands and the minds of the students. I don't want to shape it in any way. I want them to feel free, and I want them to know that I respect their thinking and that I honor it, and this is what I do. And I say to teachers, if they don't get it right away, that's okay, because they're going to be looking at other examples. So if I look at conceptual thinking and comparing and contrasting, which is what we ask children to do in math classrooms all the time, which intellectual tools do they use? And I want to give you an opportunity to think about which intellectual tools did the children use to do this, comparing and contrasting. Okay, so Deanna, you're seeing all. That's great. Is there something more that you'd want to add to that? Anything specific? And I'm happy to have you pick up the mic if you'd like. So tell me a little bit about what's their background knowledge. What's the background knowledge that they're using? Excellent. They're understanding the meaning of numbers. They're recalling how to count, one-to-one correspondence, all of these things. And they're important for them to draw on, and it's important for me to see whether there are still children who are struggling with it. I'm not going to correct yet because they're going to have other opportunities, but it's important for me to see who's struggling. As they share out this thinking, and I consolidate their thinking simply by recording it, the children who are struggling with any of these now have an opportunity to reflect. They get to think about it. They get to ask questions if they want to ask questions. What's the criteria for judgment they're using? Or let me ask, is the criteria for judgment here any different from the criteria for judgment that I modeled with them in the first few slides? What's the thinking that the children need to do? Okay, they're trying to find the understanding of the, the understanding of the symbol of equality. By the way, at this point, most of them have no clue. They really don't know. So that's the goal. And that's when I introduce the word equals, because many of them don't have the vocabulary. Okay, so I will say equals, or that's an equal sign. But notice on this slide what I asked them to do. I want to replicate what they see and talk about it with their partner. Why do I want them to do that? Okay, I want them to surface, even before I want them to surface the same amount. Why am I asking for replication? If they replicate, they're counting and they build their vocabulary, but notice what else they're doing as they're replicating. They're paying very close attention to all the details in the true example. If I didn't ask them to replicate, they wouldn't be paying attention. So a replication is hugely important. Okay, so they need to be able to replicate. So they have to be able to pay attention to all the details. Then what do they have to do? When they're describing the details that they see over here, they are, as you're saying earlier, they're connecting with what they already know and understand mathematically. So to compare and contrast, the criteria that they're using is similar because they have to first decode each of these, and they decode the other, and then they use criteria for how do I know how similar or different they are. There's two criteria for comparing and contrasting. Consistency with the number of differences or similarities. Children are really good with listing similarities. The second criteria, which is really important, is that they pull out the nature of the similarities and differences. They don't just count and tell me what all the similarities and differences. And by the way, when we use Venn diagrams in our classrooms, that's what we're really encouraging our children to do. We're encouraging them simply to list all the similarities and differences and then see where the overlap is, tells me that these are all the similarities and the rest are all differences. And it's a list type of question. It's not a thinking question. So I want them to go beyond the list type of question. I want them to be telling me, so what's the nature of the difference? And what they pull out of here in the nature of the difference, and I will ask them very explicitly, they'll say, well, there was 4 and 4 and there's 3 and 3. Okay, so at this point, that's what they've learned. That's what they come up with first, is they're making a conjecture again. Say my conjecture is that the equal sign means that on both sides of the equal sign, I have the same number of the same picture. It's a good start. It's an excellent start because they build on all that background knowledge that all of you identified. So what makes a sound good conjecture? Again, we go back to what are all the helpful clues we see? What do we know and understand about the clues we see? I want to highlight, I'm not going to talk about it too much, but I want to highlight how similar this is to making good or sound inferences, because I know that as primary teachers, you teach all the other subject areas as well. And so, for example, when I give children a picture like this, and I ask them what season, spring, summer, fall, or winter is it, and what part of the week, they're now paying attention to all the details in the picture, and they're drawing on their background knowledge based on what all those details mean for them. Okay, so if I look at the trees are green, what does that mean? Things have been growing. It's probably a growing season, a warm season. This is how we get our children to make good inferences. Good inferencing is exactly the same as good conjecturing. Exactly the same. Exactly the same metacognitive criteria. So here's the power of critical thinking. The power of critical thinking is that good thinking is good thinking across the curriculum. It doesn't just happen in math. And so children see the transferability of what happens in their math classroom. Now, I'm going to tell you, and I know this because I'm a mathematician by training, critical thinking and the metacognition behind critical thinking comes from the study of philosophers, and for the most part, philosophers who are scientists and mathematicians. So although we tend to feel more comfortable with getting our children to make sound inferences in, say, literacy, for example, the beginnings of this type of thinking actually happened in mathematics. And so what's happening is other subject areas are reaping the benefits of good mathematical thinkers and the work that they've done in the past. So we ended here, and we had 2 criteria. And I'm not going to go through every single one of the slides, but I want to highlight the iterative process. In the iterative process, we start with something simple. They come up with an idea. We go down and look at the shapes and the colors. And we notice how I add a scale. And the children start wondering whether there's a significance to the attribute of a color. And I want them to understand that perhaps they are. I want them to question. And so they raise a question of, why is that false? And that's true. It's got to be because of the colors. So why does the colors make it false? And I want them thinking about that. They haven't come to it yet, but they begin to recognize that there's something that has an impact on the value of each of these representations. Then I introduce fractions. And then there's a whole bunch of other examples, but what's really powerful about this is they go back each time and they build and deepen their understanding of the concept of equality. They do it in a very, very logical, sequential fashion that I've created for them so that every step they deepen that understanding in a way that's manageable for them. So I'm checking the time, and I just want to make sure that I don't run out of time showing you all of this. So I've highlighted for you the thinking that the students do throughout this process. They compare and contrast. As they come up with the properties of equality, they test, they hypothesize as they see more examples, they seek patterns, and they generalize those patterns. I think some of you have picked up on other things that they do. They learn how to model or represent. They're making continuous connections. Notice all of the mathematical processes that are at play as I get the children to engage in this mathematical thinking. Comparing and contrast is critical thinking. Testing, hypothesizing is conjecturing. Seeking patterns is critical thinking. I have to understand what a pattern is before I can seek it. So my criteria for seeking patterns is that I know what a pattern is, I look at all the evidence that's presented, and I see whether what I know and understand about what makes a pattern, mathematically true about a pattern, fits with what is showing in the evidence. Okay, so is that consistent? Going right back to that same criteria. And then I want them generalizing patterns. You're probably thinking a lot about how the intellectual tools are playing a role in this type of thinking, and hopefully you're seeing that all of them are. And most importantly, the role of criteria and metacognition. Children cannot compare and contrast without understanding that as they compare and contrast, they need criteria, and that they are looking not just for a list of similarities and differences, they're looking at the nature of a similarity and difference, because that gets to the big idea. As they're testing and they're hypothesizing, they're making conjectures. As they seek patterns, they're using criteria for sense making. As they generalize patterns, they're using criteria for generalizations. And if you'd like to see more on the criteria of these things, I'd be happy to send them to you. Notice that at the end, the children are now moving from inductive to deductive reasoning. Conceptual thinking is critical because what we're doing is we are teaching our children how to engage in formalized inductive reasoning. Right? So often we don't see how important it is, but if we do it enough times so that the children understand that when I engage in conceptual thinking, I'm comparing and contrasting, testing hypotheses, I look for patterns, and I generalize those patterns. This is the nature of thinking that's going on. And for each type of those thinking types, I reinforce the criteria. I am teaching my children how to engage in quality inductive reasoning. They're learning how to do inductive reasoning. And that's absolutely incredible to see young children do. Now, they need to do inductive reasoning before they can engage in deductive reasoning. So this particular slide now is showing deductive reasoning. And so the children get some examples. These are either true or false, and they have to decide, is it true or false? By the way, I try to pick examples around measurement, number sense, money, things that I see children struggle with because they haven't conceptually come to the understanding that something is equal when whatever is on both sides of the equal side is equal in value. And sometimes that requires that I make some assumptions. And this builds assumption making as a tool as well that the students, a mathematical strategy that the students need to use. They go back and they revisit. This is how the students consolidate their learning. I want to highlight the importance of student driving consolidation. If you want the students doing the thinking in the classroom, the teacher should not be annotating student work. The only way they can annotate it is if all they're doing is recording the thinking that has been communicated by the students, just the way I showed you throughout all of these slides. None of this thinking is an annotation of my own thinking. All of the thinking is an annotation of what the students have communicated to me as they've worked through and thought through how to solve this problem. Okay, so ensure that consolidation is always students consolidating their learning. Because if they don't consolidate their learning, you know, there's a saying that, you know, whoever does the thinking does the learning, and it is now supported by the neurological sciences. So it's really important that we understand and we accept that. I'm showing you this slide because we also have to have our children practicing. But remember what I said earlier, I want the children to be thinking, learning to think mathematically as they think to learn mathematics. This is what my practice for proficiency is. They now go through a series of examples and use deductive reasoning to practice the application of criteria against all the clues that they see in order to arrive at a reasoned decision. Is this true or is this false? At this point, it's absolutely outstanding how the children can interpret this many different ways. It becomes mathematically true or mathematically false based on the assumptions that they communicate. So the children are already engaged in assumption making, something that I believe, by the way, is a lost mathematical art in our classrooms right now and something that we need to rebuild. So they've got true, false, because here's the criteria. Now you'll notice the criteria, I would tweak this a little bit. This was done with the children and what the children came up with. But I would encourage, I think what they were seeing, but it got written this way, is they said that the value on both sides is the same. But they also talked about that the value depends on a number of different things. And so as I look at the value and it depends on all these different things, I need to make clear assumptions about how I'm interpreting that value. And at the end, the children go back and focus on communication. So very quickly, what background knowledge, criteria, thinking vocabulary, thinking strategies, habits of mind do the students need to bring into their final solution as they communicate their final results, their final decision? Can you think of what background knowledge are they using? And I'm hoping you can tell me pretty quickly. As they now draw this picture, what background knowledge should they be using? Okay, so they should be using the background knowledge they constructed as they identified the properties over here as they, oh, sorry, I don't have to go that far. You can see down here at the bottom, the whole class consensus. They're using all the properties they listed as what they know and understand to be mathematically true. They've constructed that learning, and now they're applying that learning. Okay, so most definitely they are now using the properties of equality in order to construct their picture. They're using criteria for what makes something equal. Absolutely. What criteria? If I ask them to justify what they create, what criteria will they be using? The properties. What thinking vocabulary will they be using? Now I want you to notice that this is different from just mathematical vocabulary, because they will talk about balance, they'll talk about the equal sign, they'll talk about equality, but that's not thinking vocabulary. What thinking vocabulary do they have to use here? Absolutely. One of the most important terms is justify, and they will do it very clearly. Justify, explain, or prove. I know this because, beautiful. Thinking, what thinking strategy are we hoping they're going to use? Hopefully they're doing something very similar to this, which is what you just highlighted, because they've practiced that intensely. And what habits of mind? That's a good question you have about whether you can print the slides, and I'm going to let Michelle answer that when we're done in a moment, because I'm not sure, to be quite honest with you. Oh, by the way, you're right. They need to, the other thinking vocabulary is criteria. Other thinking vocabulary is deductive and inductive. Children are never too young to learn the words, and they get so excited by the words that they run home and they share it with their parents. You can't imagine how impressed the parents are when the children are using words that they can define that the parents have no clue that they're talking about. And the habits of mind, absolutely. Perseverance, paying attention to detail, flexible fluid-mindedness, knowing how it's an iterative process. They're going back to what they did before, making connections and moving forward, going back to what they were thinking before, making connections and moving forward. This is a very fluid process. This is what we talk about when we speak about fluidity. Okay. I have a slide here, and I'm noticing it's 2 minutes after 9, so I want to close shortly. So I'm going to invite you to take a look at, so how do we assess for thinking? I offered that question to you earlier on in the session, but we didn't quite have an answer. We did talk a little bit about those 4 attributes, but you'll notice if I assess through the intellectual tools, then all of those 4 attributes come into play. Okay. Finally, I want to end with a slide that highlights that teaching content in math should not be the goal of math education, but rather it's a necessary intellectual tool. It is the background knowledge, the intellectual tool for solving problems, responding to provocative mathematical issues, and creating meaningful products and performances. So I thank you very much for your time. I'm hoping I haven't finished too late, and I can stay here for a little while if you have questions that you'd like me to answer. So please feel free if you have some questions you want to put in the slides, or if it's better for you, my email address was on the first slide, the cover page. So if you want to send me an email, I'm happy to answer any questions that you have as well.
Thank you, Laura. Thank you so much. And I will provide my email address as well in a second. if you allow me to send them the slides, I will do that with great pleasure. As usual, okay, fantastic, so I'll do it. As usual, I'm going to say this was again a great session of an extremely high academic level, and with some major Big Bang theory. So that was a bit of humor and fun in the middle. As I've mentioned on a number of occasions, listening to Laura is always a particularly humbling experience, at least for me personally. However, I think that I can talk for everyone tonight, saying that we are all extremely fortunate to benefit from Laura's knowledge and expertise on these complex issues. I also think that Debbie summarized particularly well the experience when she said low floor, high ceiling. For someone like me who developed a bit of an allergy to mathematics early in life, the low floor is particularly appropriate. But I must say that I never cease to marvel at the high ceiling you all reach during these OTF presentations. It's truly quite amazing and a bit humbling to read all your comments and all your ideas as the session moves on. I certainly want to thank you all for sharing your brilliance and your ideas along this entire session. And Anne-Marie, congratulations for daring to jump in. I would like to take a few more minutes of your time to let you know about some great sessions that are offered in the coming days. On April 26th, a presentation by Jennifer Evans and Erin Clisby titled Tripping Over Math in Kindergarten, so that's next week. Jennifer and Erin are new to OTF Connects. It will be their very first session. Since they are new to our OTF programs, they are not yet as well known as some of our more seasoned facilitators, like Laura, for instance, and they don't have a large number of regular followers. And for that reason, registration has been rather low for that session. So I warmly invite you to participate if you can next week. And I will also ask you to pass the invitation to your colleagues. Then on May 1st, we have our first French session of the year by Suzanne Forrester and Jeanne Rochon. And as you know, we only have a handful of sessions in French each season. And again, due to the fairly small French population in Ontario, we also have very few registrations for that session. So therefore, if you happen to know French teachers, please forward them the invitation as well. Thanks so much. And then on May 3rd, it's the opposite. We have another session that is already sold out. But for the other two, on April 26th and May 1st, we have availabilities. I'm going to quickly post in the chat box the links if you want to go onto our calendar and see what other sessions are coming up in the coming days. I also would like to tell you about another opportunity provided by OTF and the Ministry of Education. If you are a qualified teacher and you have completed an additional qualification course in math, technology, or kindergarten, you may be eligible for a $450 subsidy. So I'm going to post the link. Here's the link if you want to apply for that subsidy. As you know, your feedback is extremely important to us. When quitting Blackboard, you will be redirected to a feedback survey on tonight's session, and you will be invited to fill a short online questionnaire. The survey only takes a few minutes, so if you have the time to do it tonight, that would be greatly appreciated. Upon completing the feedback questionnaire, you will be redirected to another page, allowing you to enter your name, and then you will receive a certificate of participation to this training session that you will be able to add to your professional learning resume. If you don't have the time to do any of this tonight, don't worry, we will send you tomorrow a recording, an email with a recording of this session and all the links to these resources. But in the meantime, I will also paste them for you in the chat box. And I also would like to provide you with the link to the resource page for Laura's presentation tonight, and it will be live by tomorrow morning. So here is that link as well. So that's it. Finally, I just would like to invite you to follow OTF on social media as well as on our OTF website. I will now end the recording of the session. Please feel free to remain online if you wish to ask Laura additional questions once the recording is ended. And I will also provide you with my email. And otherwise, I wish you all a very good evening. Thank you once again for your participation in tonight's session. We hope to see you again very soon on OTF Connects. Bonne fin de soirée à tous et à toutes. Nous espérons vous revoir très bientôt sur OTF Connects. Merci.